happening between on-premise and off-premise networks. So that's about a brief recap, isn't it, right? Now, moving on to the next one, in the syllabus, we will be discussing about cloud characteristics. Okay, so in and all, you can see 6 important characteristic features. Okay, I don't say that these are the only 6 characteristics, but the list may go on. But as and when our curriculum is being concerned, okay, it was framed. Okay, so at that point of time, these are the characters that have been identified. Okay, so first character is on-demand usage, followed by ubiquitous accessing, next multi-tenancy, elasticity, measured usage, and resilience. You got it, okay? Now let us discuss uh, each of such characters today. Okay. So first one is on-demand usage. Very clearly, we were telling many a times when we talked about cloud provider or else cloud environment or else IT resource or else resource allocation. Many a times we were telling that even when we were talking about cost factor and the reduction of the cost factor as well. Okay, we were telling that IT resource can be consumed as and when it is needed, and that has to be provided only on demand by the client, by the client, and that provision should be done by the provider. You got it? That means the demand should be on the client side, and the provider, as per the agreement, he will be providing the resources. Okay, so this is what we call as on-demand usage. Okay, if I really need it, then I go ahead and use it. Otherwise, I don't need it. I don't need it. Okay, so many of the examples you can be considering, isn't it? Right? Like one good example I would like to give here is people are fond of having accessories, isn't it? Okay, so people often buy watches and other accessories in matching with their dresses. That doesn't mean that okay, you have that resource and you are supposed to use it all the time. It means that you have 2 watches and you wear all the 2 watches all the time. Does it make sense? No, isn't it? Okay, it depends upon the demand. It depends upon the demand. You have purchased those devices, or else you have that resource access. Okay, resource access. That doesn't mean that you can use it all the time, isn't it? Okay, whenever it is needed. Whenever it is needed. Usually, what happens when 2 watches are there between the siblings? Okay, they will be exchanging accordingly. Sometimes, okay, brother will be wearing one watch and another elder brother or else younger brother will be wearing other watch. Okay, if they get bored or else they will be exchanging. So it all happens on the demands. Okay, it all happens on the demand. So similarly, here the resources which are available in the cloud by the provider for the consumer will be entirely based upon on-demand usage. That sort of characteristic feature is available in the cloud. Okay, so if any environment which is providing on-demand access of its IT resources, then you can name that as a cloud. That's it. Okay. And second one, ubiquitous access. Ubiquitous access. What does ubiquitous mean? What does ubiquitous mean? So the basic meaning of ubiquitous is anywhere or everywhere. In other words, it can be called as everywhere. You can access your resources at any point of time and every point of time. At every point of time. Simple. Now you people are accessing your mails from your home, from your mobile, from your PCs, from your desktop, from college, or even while you're traveling. That means you are having access all the time. You are having access all the time. And from any location and by all other means also you can have the access. Okay, there is no limit restriction or limitation in that. Okay, probably the visibility or else the settings might be the configuration settings might give a little bit variation in the display in mobiles and in the laptops or in the desktops. Okay, but still you are directly accessible to the all the resources that are available for you, isn't it? So that makes ubiquitous. Okay, so this the cloud which has its resources for the cloud consumer is ready to provide access to its resources at any point of time and from everywhere. Only the thing that will be required for accessibility is the network. the internet, isn't it? Right? Okay. So that's about ubiquitous access. Next characteristic feature is multi-tenancy. Multi-tenancy. That means here it is, you can call as something like multiple consumers are there being access to one such service. Let us assume there is one service. Let us assume there is one service. Maybe the service can be consumed by multiple tenants, in a sense, consumers, multiple consumers at the same time, maybe from different location and in a different senses. And in different senses. For example, though you have logged into your Gmail, okay, though you have logged into your Gmail, from the mobile, you can see the mails. Still, at the same time, you can also open your laptop or desktop or any other, like a tab or any other device, okay, and still you can have the access to your mails, isn't it? So that is multi-tenancy. Here, the service is being accessed from the mobile and from the laptop or any other device, isn't it? Right? So this is what you call it as multi-tenancy. Okay, and there is a few differences also. Here in the example, I have told one service, one consumer, one service, one consumer. But similarly, I can have multiple services to one consumer. Okay, multiple services to one consumer and multiple services to single consumer or multiple customers or multiple consumers as well, isn't it? Like, okay, if I have okay, in the mail I can access in the mobile I can access email, and on the desktop I might be accessing photos, and on the tab I might be accessing YouTube, but all are from Gmail only. That is G Suite, isn't it? Right? So it purely supports multi-tenancy. That's what we call it as. That's what we call it as. But never ever, okay, the data of one user will not be mingled or else will not be clubbed with the data of other consumer. Okay, though the consumers are consuming the same service at a time, maybe in the same location also. Okay, so that sort of categorization of the data or else the categorization of consumption of the service is being taken care of. Okay, so in the slide what you are seeing is single tenant environment where, okay, each yeah, each consumer has their own separate services, and all these two services are hosted on the same cloud. That means here in the same cloud, in one cloud, you can see there are two services, that is service A and service B. Okay, and service A is directly dedicated to the consumer A, and service B is directly dedicated to the consumer B. Still, the cloud can cater whatever the needs of consumer A in terms of service A. Similarly, whatever the needs of consumer B in terms of service B. You got it? Okay. All these things can be happening in a single environment. And you call this sort of environment as single tenant environment. There is another kind of environment where there are multiple services, or there is a single service that can be catering between two consumers, See, in the previous example, cloud service A was having access to storage device A, and cloud service B was having storage to device B. But in this environment, in this multi-tenant environment, you could see both again service A and service B catering consumer A and consumer B respectively. But both of these services are accessing the same database. The same database. As I told you, the data will be properly handled in such a way that there will not be conjunction of the consumer A data or else consumer B data. You got it? Okay. So this is about the multi-tenancy. Is that fine? Okay. Now moving on to the next important characteristic feature is the elasticity. Elasticity. As we were telling that cloud should be scalable. Obviously, elasticity is the only property that allows scalability to happen. That means this should be That means this environment should be having an ability to appropriately scale the resources. To appropriately scale the resources. Any environment having this ability, you can call that as a cloud. It's as simple as that. Any environment which has an ability to scale appropriately, then you call that environment as a cloud. Okay, so it should be scalable enough. That's what it means. Okay, and other thing is measured usage, and this is a quite interesting one. Whatever the resources that are available till now, we were discussing is that resource should be on demand, it should be everywhere available, it should be anytime available, and it should be multi-tenant, in the sense my data I should access, and I don't mind if the same environment is being used by others. Okay, and if I require I should scale upon my resources. Yes, all are fine, but all these things should be measured. All these things should be measured. Why? Because the cloud purely follows pay per use concept. So in order to pay per use, okay, you need to scale, or else, sorry, you need to measure the usage scales. You need to measure the usage scales, and hence without measuring, okay, it is literally tough for you to calculate how much you are going to charge for the usage, isn't it? Okay, so they should be properly measured. They should be properly measured. And this charging and how the measurement units and the financial terms, though this particular characteristic includes a little bit of finance in it. Okay, these finance matters are well defined and described in SLAs. SLAs. Remember, we will never be using this measured usage for tracking the statistics only, but it is also to ensure that whether the scalability is required or not. We just now, in the previous characteristic feature, we told that the IT resources should be scalable enough, isn't it, right? So in order to identify that, yes, if we have to scale, okay? So this measured usage literally informs the administrator that it's time for you to scale upon. It's as simple as that, isn't it, right? Okay, so that's the other characteristic feature. Now, the last character, that is resiliency character, okay? And at times it is said that NIST, National Institute of Standards and Technology, don't claim the resiliency as one of the characteristic feature of the cloud. But still, some other what to say organizations, okay, they see that resiliency is also a characteristic feature of a cloud. Okay, basically, what is resiliency? What is resiliency? Usually when I talk to you people, okay, when I talk to you people, I take the help of CR, isn't it? I take the help of CR. If CR is absent, or else if CR is not available, whom should I approach? I will be approaching LR. And if in case both are absent, what should I do then? What should I do then? I should find some other person, isn't it? So what exactly I'm looking for? I'm trying to create a backup of my communication, isn't it? Okay, if CR is not available, okay, I will be looking for some other person. I'll be looking for some other person to have the communication done properly, isn't it? Right? Right. So this is what we call it as the resilient. That means in the cloud, probably if there is a server and this server delivers certain service and there are consumers consuming this service properly, this will be the regular scenario. But for some unknown reasons, if the server is gone down, if that server is gone down, automatically what happens? That service is also said to be gone down, isn't it, right? But the consumer doesn't bothers about it. He wants all the time the service, okay? So as a cloud resource administrator, you need to take care of in such a way that if this particular server goes down, automatically there should be a backup server with running the same service, and automatically all the requests will be diverted to that server for service consumption. You got it? It is like example, in a layman example, I can tell that when the power is off, automatically the inverter switches on, isn't it? Okay, so that's what you call it as the backup actually. That is the backup. But here, there is a problem is being occurred. There is a problem is being occurred, and that problem will be solved on its own based upon certain backup or any other method. Any other method. See why I am telling any other method, because usually backups are created. Backups are helpful when servers go down, or else when some amount of data is lost. Okay, then backup will be a great boon for you to recover. That is agreed upon. That is agreed. But what happens in certain services, especially when the financial services are being happening, when the financial services are being consumed, especially on the other day, I was telling you an example of ATM cash deposit machines, isn't it? Okay, if power was not there, and after me inserting the money, if the connection lost, then money will not be thrown back. At the same time, it is not entered into my account, isn't it? Okay, so those kind of problems will be coming upon. So in such a case, neither the power backup will be helpful, nor the data backup will be helpful at that time, which is I cannot tell that only backup is the only method of resiliency. But in the cloud, the service it itself gets the repair. There's some amount of intelligence. Why? Because in the cloud computing, you can have certain amount of intelligence, and you can have a tracking of such kind of requests. Even it can identify anonymous requests, or else what to say, spam requests also, and it can control upon such requests. So all these things can be categorized under certain problems. Okay, and the resilience talks about if any problem is occurred, automatically the system has to show some sort of resistance to that particular problem, and very quickly it get back to normal service situation. Then at that point of time, you call that as a resilience. You got it? Okay, so that's about resilient computing as well. Okay, usually NIST doesn't take that cloud is a resilient, cloud should be resilient. Okay, it has its own reasons. Why? Because the problems that can be occurring in the cloud may not be held responsible all the time from the cloud only. If the network in between is lost, then how can you hold cloud as a responsible? Something like, okay, you don't have mobile data in your mobile and you want to access Gmail, and if it is not accessible, can you file a case on Gmail? No, you cannot do that. You cannot blame Gmail for that, isn't it? It's you have to have the network, isn't it? So that is one sort of example why NIST dropped this resiliency from the characteristic feature of the cloud. It cannot be. It cannot be. Why? Because there are many entities which are out of control of the cloud, which are out of control of the cloud. Not only this, which are there are few entities which are also out of SLA, that is service level agreement. SLA, that is service level agreement. See, usually like when you buy a ticket for a movie, you go in, and because of some reason the movie is stopped in the middle, you cannot demand the cash back, or else you cannot ask him to play the movie at later point of time. You have to walk out. That's it. Why? Because the ticket, though it says that okay, you are paying that money for that. That is the kind of agreement, isn't it? Okay, though you are paying for that, but there are few uncontrollable situations where you cannot have the things done according to the agreement. Okay, so likewise, cloud has many such issues, and SLAs, that is service level agreement, has many such problematic issues for that matter, which cannot insist upon the resiliency in the cloud. Am I clear on this? Okay. That's about the characteristic features. Once again, I will repeat the characters, the 6 characters. First character is on-demand usage at any point of time. You should be, the IT resource should be made available or else consumable whenever the need is there. And second one is ubiquitous access, which means that at any point of time and everywhere, you should be accessing your resources. And these resources are definitely multi-tenant. Multi-tenancy is allowed. That means single tenant environment or multi-tenant environment. In both the kind of environments, okay, the multi-tenancy should be gracefully followed and allowed. And the fourth characteristic feature is elasticity. The environment should be scalable enough, okay. And the fifth one is measured usage. Yeah, obviously cloud is entirely pay per use model, and hence definitely you are supposed to measure what the service is being consumed. And also it helps us to understand when exactly you are supposed to scale and when you got to cut down your scaling factors. And the final one is the resilience, isn't it, right? Okay, this is about uh, the 6 characteristic features of the cloud.